in this video. So let's start with the next topic, yeah, that is graphical representation of motion. So we have different types of graph here that we have to consider. That is graphical representation. You have to make notes in your Find a Fair notebook. Graphical representation of motion. So first thing we have, that is distance time graph. After that we have velocity time graph. So first to consider the distance time graph. For example, if body is at rest, we take two axes, that is, like for example, I'll explain you. This is distance that you take in meter, this is time that you take in second. So if I said body is at rest, if body is rest, that means at time 0 second it is at this second, at time 1 second, at time 2 second, 3 second, 4 second, body is at rest. That means for this 1 second body is at 100 meter, for example, for 2 here, for 3 here, for so whenever a body is at rest for distance time graph, the graph is like this. And for second case, when body is at rest, second, that is distance time graph for uniform motion. Uniform motion, you all know that I have told you so many times, when a body covers equal distance in equal intervals of time. For example, if I say just let me draw the graph. This is distance and this is time. Graph would be like this. ऐसा क्यों? Because देखो, like distance and time, for example, at time here and distance is here. 0 second distance is 0, at 2 second distance is 5, at 4 second distance is 10, at 6 second distance is 15, at 8 second distance is 20. So if you see that in every 2 second distance increases 5 meter, in every 2 second. For example, if I put the values 2, 4, 6, 8, 5, 10, 15 and 20. For 2 it is at 5 like this, for 4 it is at 10, for 6 it is at 15, and for 20 it is at 8. So it is uniformly increases with respect to time. So it is called distance time graph for uniform motion. And for obviously non-uniform motion, your graph would be like, you all can, I hope you will get this part. When a body cover unequal distance, if I change these values, for example, time and distance have values. At 0 it is 0, at 2 it is 5, but at 4 it is 18, at 6 it is again, it is constantly increasing, but it is 20. So you can say that at every value there is a different value. So it is a graph for non-uniform motion. These three cases are in your book, that is page number, you can say that 104, the distance time graph for a uniform motion. For distance time graph, that is when body is at rest, when body is in uniform motion, and when body is in non-uniform motion. So I hope you get this. Second thing you have to discuss is about velocity time graph. That is very much important. Velocity time graph for uniform motion. Velocity time graph for a uniform motion. That is first case, you can say that velocity time graph when body is traveling, when a velocity time graph for uniform motion of a car, when a body is traveling with uniform motion, that is like this. Here at x-axis you are taking, y-axis I am taking velocity, and units is meter per second, time your seconds. So when body is moving in uniform motion, so that means at 0 second its velocity is 0, at this is time and this is your velocity, at 5 second its velocity is, well, let it be 40 meter per second, at 10 second its velocity is same 40 meter per second, at 15 second it has same 40 meter per second, At 20 seconds its velocity is 40. That is, velocity is constant. If velocity is constant, for example this 20 and this is 40, at every point of time 5, 10, 15 and 20 velocity is same. If velocity is same, you can say that for 5 velocity is 40, point will be here. At 10 velocity is 40, point will be here. At 15 point will be here. At 20 point will be here. So graph would be like, your graph would be like this, and this is the velocity time graph for a uniform motion. Next you have a velocity time graph for a car moving with uniform acceleration. Obviously non-uniform motion, you can say that same like this. Time and second, you can, I hope you will understand. At 0 second it is 0, at 5 second it is 10, at 10 second it is 30, at 15 second it is 35. Non-uniformly, it is increasing, but it is increasing non-uniformly. Here the velocity is for uniform motion is constant. So this is the part, velocity time graph for a uniform motion. Next we have velocity time graph for a uniform acceleration and non-acceleration. Velocity time graph for a uniform acceleration. For uniform acceleration, you can say that acceleration is constant. So I hope you will get this part, but there is one thing I want to tell you, that is velocity time graph. Obviously for uniform acceleration it would be this. For this is for uniform acceleration when acceleration is constant. Non-uniform acceleration, the graph would be this thing, time, second. But it is a third graph I want to consider, that is for retardation case when velocity is decreasing. Like for example, you can say that at 0 second velocity is 0, at 2 second velocity decreases. For example, I have final velocity, I have 54. For after that I am considering the at 4 second, this is time and this is your velocity 54, then at 6, then at 8 and 10. So 54, 36, 27 and 80. So velocity is decreasing with respect to time. In that case your graph would be like this, uniformly or non-uniformly decreasing with respect to time, because time is here and velocity is here. So you can say that velocity is decreasing with respect to time. 54, 36, 27, 54, 36, 18 yahi kahin hoga, there would be 18. So velocity time graph would be decreasing with respect to time. So this is called your graph. So I hope you consider that case and consider these all different types of graph, and you have to make notes in your physics notebook. So we'll make the next video, I'll make like graphical equations of motion, where I will tell you the equations of motion which we have to do the numerical part. So that's it for this video. So try and the more questions for the acceleration. Thank you.